Okay, so what we're going to do now is we're going to look at what's called a combination, right? So we're going to start off with an example. In how many ways can I choose a group of 3 boys from a group of 5 boys? Now, if we have a look uh, at the permutation, we will remember that 5 permutation 3 was 60, right? That is when I'm concerned about the order. In other words, I'd count ABC differently to BAC, differently to ACB, differently to BCA. However, this question here, in how many ways can I choose a group of 3 boys from 5 boys? That group must be counted in exactly the same way as that group, and that's why I've shaded all those ones yellow, right? So you see, in fact, that there are 6 times as many if we are concerned with the order. If I'm counting a combination, I just want to count that once. So in fact, this answer of 60 that I had previously would need to be divided by 6. So in fact, there are only 10 different ways I can choose a group of 3 boys from a group of 5 boys. There's a sort of yellow version, the green version, the blue version, and if you count them, you'll see that there are 10. This 6 is actually 60 over 3 factorial. And the reason it's 3 factorial is because this grouping here, ABC, can be arranged in 3 factorial or 6 different ways. There are 1, 2, 3, 4, 5, 6. So if I'm just selecting a group of 3 boys from 5 boys, there are 10 different ways I can do that. Let's look at another example. Again, one that is similar to the one that we looked at with the permutations. In how many ways can I choose a group of 2 people from a group of 6? Well, they're the permutations, and you might remember that there were 30 of them, right? However, this was AB different to BA. Here, I want to count those 2 just as 1. So I've shaded again. I've shaded them in yellow. So basically, if I worked out 6 permutation 2, I would get 30, but I need to divide that answer by 2 factorial. And the reason I'm dividing by 2 factorial is that the 2 could be arranged in 2 factorial different ways. If I've chosen A and B, it could be arranged as A and B, B and A. If it was a permutation, I would count them separately. I'd count them as different from one another. But if I'm just interested in choosing a group of 2, then this group is the same group as that group, and I need to therefore divide by 2 to get my final answer of 15. There are 15 ways I can choose a group of 2 from a group of 6. So we now have a formula for what's called a combination. And the way this formula looks is as follows. It's NCR equals N factorial N minus R factorial over R factorial. And that R factorial is dividing out for the repeated the repeated version in the permutation, but we don't want to count in the combination. So let's just take a look at an example. Back to, in how many ways can I choose a group of 5 boys from a group of 2, right, if the order doesn't matter. And remember, the formula looks like this. N factorial over N minus R factorial R factorial. And our calculator can do this. Let's just bring up the calculator. Here it is. And we get 5 combination 2 is 10. Let's just check this out. Suppose the boys were called A, B, C, D, and E. I could take A and B. I could take A and C. I could take A and D, A and E. I haven't taken B with C. I haven't taken B with D. I haven't taken B with E. Notice I have taken B with A over there. I could take C with D, and I could take C with E, and lastly I could take D with E. Right, and if we add these up, we get 4, 7, 9, 10. Right, there are 10 ways in which I can take 2 objects from 5 objects if I'm not concerned with the order in which I select them. Notice, just for interest's sake, that 5 combination 3 is also going to equal 10. And the reason for that, if we look at the formula, all that happens is instead of having 5 factorial over 3 factorial, 2 factorial, if I'm going 5 combination 3, I'll have 5 factorial over 3 factorial, 2 factorial. So I get exactly the same answer. And it also shouldn't surprise us because when I choose A, B, C, sorry, when I choose A and B, I'm actually not choosing C, D, and E. And when I choose B and C, I'm not choosing A, D, and E. So there'll be exactly the same number of choices for 3 people from 5 as there will be for 2 people from 5. Just to sort of reinforce that, the number of ways in which I could take 11 people from 4 would be exactly the same as the number of ways I could take 4 people from 11 would be the same as 7 people from 11. Because combinations occur very frequently in maths, we have another notation for them. So 11 combination 4 can also be written like this. There's no fraction line, it's just a bracket with these two numbers, one over the other. This is the number of ways I can choose 4 objects from 11 objects if the order in which I choose them does not matter.